Hi gentlemen, and welcome to flip number 7 on covalent bonding. And our key question today, what are covalent bonds and where do we see them in nature? So to review quickly, ionic bonds, we talked about last flip, usually occur between a metal and a non-metal. So again, if you remember that left side of the periodic table, mostly metals, the right side of the non-metals. Okay, the metals, or sometimes if it's a positive ion, will donate one or more electrons to the negative ion, so generally the non-metal is the negative ion. Ionic bonds are very strong, and generally they're solids at room temperature. They conduct electricity as well. Okay? Covalent bonds have a bit of a different twist to them. Okay, so in terms of an ionic bond, you had one atom donating an electron to another. In the case of a covalent bond, electrons are actually shared between two atoms. So let me show you what that looks like here. If I go to my gizmo here, as we call it. Okay, so an example here, as you can see, let's go with a simple example to start. Hydrogen. We have our nucleus with one proton and no neutrons, and one electron in each case. So in the terms of hydrogen, you're going to see they're going to try and fill their electrons by their orbitals by sharing. And so now what happens is, hydrogen, we know, only has that first valence shell, and that first shell of electrons only needs 2 electrons to fill it. So both of these hydrogens want an extra electron. So to do that, right? So they originally have 1. They would like to have 2 or none. So rather than donate 1, they share both of them. So now they both have the 2 in that valence shell. Let's look at a more detailed example of fluorine. Okay, so fluorine, you have 7 electrons in the valence shell, and there are 2 in the inside shell of each of these as well, but we're going to skip that part. Okay, so there's 7 orbiting around. Again, this is simple version, but again, if you take an electron from each one, put it in the other, you can now see these 2 electrons shared between the 2 atoms, and so it becomes a shared pair of electrons between the 2. Okay? And so sometimes you have the case of nitrogen, okay, where you have those 5 valence electrons. In the terms of nitrogen now, you need to share 3 electrons between the 2. So you're going to have to actually have 3 from each being shared. Okay, and then you have that much larger, that bonding. We call that a triple bond, and we'll do a little bit of drawing of those in the future. But you see now, to get that full valence shell, to get those outer 8, we're sharing the electrons. Let's go back to a simpler version here of, let's say, chlorine. All right, so again, 7 valence electrons. I'm just going to take 1 from each and split them between the 2. And so now you can see the 2 electrons shared between the 2 atoms. So this is their sharing electrons in order to fill that valence shell. Okay, let's go back here, and that's how those covalent bonds work. They're always between 2 non-metals. Okay, so in terms of a metal can always give up and donate that electron. Here we have a bond between 2 non-metals, and so neither can donate. They both want to take on electron, and so to avoid that issue, or to solve that issue, they generally share electrons. Okay? A very common one we see is water. Another example is oil. So oil and water are both examples of covalent compounds. Generally, you can see them as solids, something like sugar at room temperature, or a liquid like water at room temperature, or gases, oxygen gas, hydrogen gas, like we saw. Those are examples. Those are covalent compounds that are gases at room temperature. Okay, carbon dioxide, carbon monoxide, more examples. Okay, generally they're good insulators, which means they do not conduct electricity very well. Because they're not ions, ions generally allow electrons to move a little bit better. They have low boiling points, so where the ionic compounds have very high boiling point, covalent compounds in contrast have very low boiling point. And generally the bonds are not as strong as those in ionic bonds, which is why you have the lower boiling points in this case. Okay, so let me show you some drawings and how we were to demonstrate this. So I'm going to go to this worksheet that you guys are going to be working on shortly when you're in class, and do a couple examples. So a good example, or one thing to always remember, one thing you guys are aware of is obviously water now is a covalent compound. But one thing when you're drawing these to keep in mind, if there's a single atom anywhere in the drawing, that one is going to go in the middle. Okay, so in the case of water, we're going to just draw the Lewis structure for water. So if you remember in the periodic table, water had 6 valence electrons, and hydrogen had 1. Okay, and so now hydrogen would like to gain an electron or lose it, and oxygen would like to take on 2 because it's got this space here for 2. So what you're going to do is now each electron that's sort of included in this bonding counts for both atoms. So this electron here for hydrogen bonds with one of the electrons from oxygen, and same on the other side. And so now each of those electrons counts on both. So 1, 2 for hydrogen, 1, 2 for this hydrogen. So both hydrogens are happy. If you count the 1, 2, 3, 4 for oxygen, then 5, 6, and 7, 8, now oxygen is happy. So as soon as this bond happens, every electron that's involved is included in both. So they're counted among all of them. Okay? A bigger example here is carbon, okay, with its 4 valence electrons, okay, and then chlorine with its 7. Sorry, chlorine. We have 4 chlorines, as you can see here. And obviously carbon, there's only one of them, so the carbon goes in the middle. And so now all you're going to do, we know carbon wants 4 more. Chlorine would like 1 more in each case. So by joining these up, okay, now chlorine in each case has its 7, 8, 7, 1 more 8, and then 1, 2, 3, 4, 5, 6, 7, 8 for carbon. Everybody's happy. Okay, now sometimes, like in the case of nitrogen, one bond isn't going to cut it. We have N2, so we have 2 nitrogens. The funny thing about nitrogen, though, is nitrogen has 5 valence electrons, if you remember correctly. Okay, if I do one bond across between the 2, I still have my 5, and I'm only adding a 6. Okay, if I have my 6 and I add another one, now I have 7, right? 1, 2, 3, 4, 5, 6, 7. So I need to do a 3rd bond, and we call that a triple bond. So now if I count 1, 2, 3, 4, 5, 6, 7, 8, now my nitrogens are both happy. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so sometimes that's something you may run into. Okay, when you come to class, we'll get a chance to do practice here, and hopefully we'll get a better understanding of it. Okay, good luck.